Now that we have learned about the electric charges, let's perform some activities to understand these charges better. Let us take a PVC pipe and rub it against the woolen cloth. If we take this pipe and bring it near the pieces of paper, what will happen? These pieces of paper get attracted to it. Will we get the same behavior if we rub this PVC pipe with a sailcloth? Let's try it. Yes, we can attract these paper pieces to the pipe when we rub it with sailcloth. What other things PVC pipe can attract or repel? Try with stream of water, plastic straws, cold drink cans, dry leaves. Same activity you can perform with other materials instead of PVC pipe. Can we generate static charges on metal? This attraction of paper pieces does not tell us anything about the nature of net charge on the PVC pipe. How will you detect if any object is charged or not? We can build simple device called electroscope. Let us cut this aluminum foil into thin strips and make a small hole. Small hole is made in the bottle cap and cycle spoke is inserted through the same. Now let us place these two strips of aluminum on the cycle spoke. We will close the lid of the glass bottle. We know that metal is a good conductor of electrons. When we take any charged objects nearby, it repels similar charge all the way towards the other end of the electroscope. These are one type of charges. They are also present on the thin aluminum strip. This is used for food wrapping. Since like charges repel, we can say that object which is taken near the electroscope is a charged object. Uncharged objects do not result in any movement of the thin strip. What will happen if you rub for some more time? Will it result in more repulsion? If we rub it for more charges will be present on the PVC pipe and distance between two aluminum strips increase. If we touch the electroscope with our hands, thin aluminum strips will collapse as our body carries the charges out of the electroscope into the earth. There are no charges to the strip now. In laboratory, electroscopes are much sophisticated devices. They are made up of big glass containers and have gold leaf instead of aluminum strips we used. All objects are charged. When positive charges are more, we say that it is positively charged. When negative charges are more, we say that it is negatively charged. When both charges are equal, we say that objects are neutrally charged. They do not have any specific charge. Lightning occurs when there is a buildup of charges in the cloud. We learn more about it with the help of some animation. Lightning is the most amazing natural phenomena. Sky is full of dark clouds. These are just floating around. What does a typical cloud contain? These contain water vapors and some tiny particles of ice. There is a continuous movement between these particles in the cloud. Under stormy conditions, this movement picks up speed. Within the cloud, small storm occurs. Particles brush against each other. Some ice particles are heavy and some are light. Lighter particles move in the upper part while heavier ones move to the bottom. During this shift, they brush against each other. This results in lighter particles getting positively charged and heavier particles getting negatively charged. Once sufficient charges are built, there is a spark produced and we see lightning in the sky. This lightning is within the clouds. This is first type of lightning. There is no thunder in this case. Most of the lightning is of this type. When two charged clouds come together, lightning occurs in between those clouds. We can hear loud noise and thunder when this type of lightning occurs. This is second type of lightning. Third type of lightning occurs between clouds and the ground. Earth and objects on the ground are normally neutral. They are not positively or negatively charged. Sometimes clouds build up or gather charges so much that these repel negative charges on the ground. This leaves other objects like building, temples, trees positively charged. Excess negative charges of the cloud are attracted towards positive charges on the ground. But how will these charges flow? Air is a bad conductor of electricity. But if accumulated charges are very large, it becomes a conductor and allow charges to flow. This results in lightning. Heavy heat produced during the lightning. This happens in a very short amount of time. Heated air expands very fast and pushes the cold air at a very high speed. This results in sonic boom produced and we hear loud thunder. You must have heard that lightning strike can cause damage to structures like buildings, trees. Most of the time, structures or trees catches fire. This is due to large amount of heat energy associated with the lightning. To protect these, we must provide safe path for lightning towards the ground. Lightning rod protects structure from lightning. It is made up of good conductor, normally copper or some alloy. Lightning rod is connected to earth as this rod is placed just above the topmost part of the structure. Rod is connected by a good metal conductor all the way to the ground. When lightning strikes, all the negative charges use lightning rod to move towards earth without causing any damage to the structure. This protects the structure as well as its surroundings. Every second, approximately 50 lightnings occur somewhere in the world. If that is amount of negative charge earth receives, it should be negatively charged, right? Actually, earth is very massive compared to the charges it receives during lightning. Earth is considered as a very large sink. Just like we adding a few drops to a huge ocean won't change any level. Adding few charges to the earth does not change its natural or neutral feature. You must have heard the phrase, when thunder roars, go indoors. What precautions you should take during that thunderstorm? The best place is to be indoors. If it is not an option, it is best to get as low to the ground as possible. You do not want to be the tallest thing around in the thunderstorm. Avoid taking shelter under trees. Summary. We learn more about the charges by doing activities with everyday things. We also built electroscope. With the help of animation, we found out why the lightning occurs. Learn more about static electricity with the help of internet.